Okay, if we are going to graph the equation as shown here, what we want to first do is go through the shaft process that we had worked on earlier in the semester. And remember that shaft stands for shift, amplitude, period, and picture. And kind of do an easy one first. The picture is just going to be a sine curve, so it's going to start in the center, head upward since the the amplitude was positive. The amp is the number out front for the word sine, so in this case 3. The period is always 2 pi over the b value. And the b value, for every question, is the number that we see in front of the parentheses. So this will be 2 pi over pi over 3, which means we're going to get 2 pi times 3 over pi, which becomes 6. And so our period is now 6. The shift is based upon these numbers that we see up here. So the vertical and horizontal shifts will always be the opposite of what's labeled. So our vertical shift will be up 2, and the horizontal shift will be left 1. All right. Now, since there's a shift involved, it's a good idea to consider what the graph would look like if it did start at 0. And if it started at 0, it would end where the period does, which the period is 6, and then the next one would end at 12. But since there's a horizontal shift and it's moving to the left, what we want to do is go ahead and subtract opposite of the horizontal shift. So we're going to subtract 1 from each of these, which means our first curve is going to start at -1, finish at 5, and then the second curve will finish at 11. All right, so now when we go to graph this, we're just going to piece all of this onto the graph, kind of starting with the shift process that we just figured out. So making a rough sketch of this, we're going to have, since we're moving up 2, I'm going to leave plenty of room up above the picture. And the graph actually started at -1 on the x-axis. So I'm going to go back here to -1. And the first period is going to end at 5. So if we kind of space that out so that it looks nice, we want to make sure that this gap stays the same when we mark the end of the second period. And I'm going to erase those squiggles now, but just to kind of visualize that, we can see what that's going to look like. So let me finish erasing that. All right, and so again, just to kind of partition this up, I'm going to put dashed marks at the beginning and end of every period, so we know where they're starting and finishing. It's shifting up 2, so let's mark 2 up here. And that's actually going to be the middle of the graph. So I'm going to write the word middle here. And since our amp is 3, that means the bottom of the graph is going to go down 3 units. And then the top of the graph is going to be up 3 units. So this is my amp of 3. So I'm going to go down to -1 and up to +5. Okay, so now that we have our boundaries established, we can start averaging the x-axis. And if we average 5 and 11, we can just add those and divide by 2. So 16 divided by 2 is 8. And if we work that going kind of in between there, we'll just continue adding and dividing by 2. So we get 13 halves, 19 halves. And I like to watch trends on this. So I'm going to highlight some numbers in red. And notice that the numbers that we see in red all decrease by 3. So that means this next one here is going to be 2. And again, looking for patterns, focusing on the blue numbers, those all have a denominator of 2. And if you look at the numerators, they're decreasing by 6 as you move to the left. So 19 take away 6 is 13. 13 take away 6 is 7. 7 take away 6 is 1. And if you see that pattern, we can use that instead of averaging every time. So now that I have this set up, I'm going to sketch my positive sine curve in. And sine curves start in the middle, and then they go high, middle, low, middle, high, middle, low, and middle. So we end up with a curve that looks something like this.